You learn the differentiation rules.
So which ones?
Well, if you have x to the power of n,
Yeah, I know that. It will be
what's the result?
nx n minus 1.
Okay. But here, you must not only do that. So like here right now, this 7 will go down.
Yes.
You're going to have x squared minus 11x plus 24. And the power becomes 6. But now you have one more step. You know what that is?
The inner.
Yeah, you must take the derivative of the inner one. So go ahead. What's the derivative of x squared?
We cancel 24 since it's a constant.
Nice. Okay. X squared becomes what?
It becomes 2x.
2x. And how about minus 11x?
Becomes minus 11.
So we got our answer, right?
Yes.
Very good.
So we keep after finding the first derivative, we keep the whole equation and then we multiply it by the
by the
one.
inside derivative.
It's the highest order derivative, right?
The what order derivative?
Highest order.
What are you talking about?
It's like going much more.
Oh, it's called chain rule.
Chain rule.
Okay, this is like painful. Okay.
Do I take them?
Yeah, I think. Okay, so for this question, right, we have to integrate 1 over a square root. Now, I never like to integrate anything that's in the denominator. I always like to integrate when it's a numerator. It's much easier for me.
So multiply by root x.
No. So just bring that root of x to the top.
Okay.
And if you did, right now, what's the power on this?
1.
No, it's half.
1 over 2.
You bring it up, it becomes
negative 1.
Integral from 1 to k dx. Now, what's the integral of x to the power of negative half? Would you know?
I don't think I studied integral.
Well, look, it's actually, so if you want to integrate, you do xn plus 1 over n plus 1.
It's the opposite of that.
Yeah, so it's going to be minus half plus 1 over minus half plus 1. And this integral becomes a straight line, a vertical line, from 1 to k. Now let's simplify what's going on here. So x to the power of negative half plus 1 will be root of x over minus half plus 1 is just a half from 1 to k. And, imagine if you are dividing 1 by half, how much would you get? 2, right?
Yes.
So this becomes a 2. And now you can apply the values. So you're going to do 2, open parentheses, root x minus root x again. One time you put the top number, which is k. One time put the bottom number, which is 1. So we'll get 2 parentheses root k minus 1. Now, the whole thing was equal to a 10, if you recall. So now divide everything by 2. So root k minus 1 is equal to 5. And so root k is equal to 5 plus 1. So root k is equal to 6. Now what do? I square both sides. So k is equal to 36. So that will be B. Question 3. The graph of the function f is shown in the interval. The function is defined by this equation. So right now, if you were to integrate the graph, which means find the area of the graph, you would get g of x. You would. Okay. So look at A. G is decreasing from 2 to an 8. That's actually not true. Let me tell you why. So G is the integral of f, correct?
Yes.
So that means it's the area of the graph. So from 2 to 8, here you have all this positive area. And then you end up with some negative. But in total, So net amount is positive,
Positive.
right? Because the amount positive is more. So it's actually not true. Not true. Let's look at choice B. The G is increasing from 1 to 6. From 1 to 6. The area is positive.
Positive.
That means, yes, it is increasing. So that's going to be choice B. Nice. Now, question 4. We're seeing that we're given the equation for y. Do you know what this is? This is called the second derivative.
Yeah, that's what I meant by highest order.
Oh, okay. Interesting. So you got to differentiate first time.
Yes.
You got to differentiate the second time as well. So let's take this equation and differentiate. What's the derivative of sine?
Cosine.
Wow, that's good. And you keep the inside as it is, then multiply by the derivative of the inside.
It will be 3x squared.
Nice. Now, do you know what the product rule is about? Did you reach that part?
No.
When you have a variable multiplied by another variable, and I want to differentiate, we call it the product rule. Okay? So that means you will have a times b prime plus a prime times b. Yeah. So the a is cosine x cubed, right?
You leave it as it is.
Yep. Now let's just find the b prime and the a prime before I actually apply the product rule. So let's find the a prime. That means what's the derivative of cosine x cubed?
So we first do the cosine, which would be negative sine.
Nice.
Minus 3x
Nice. And now let's do the b prime.
would be 6x.
Nice. Very good. Now let's do it. So a times b prime plus a prime, which is negative sine x cubed times 3x squared times b.
3x.
Okay. Now let's just take care of this plus with minus, so the whole thing becomes minus, right? And 3x squared times 3x squared is 9x, the power of 4. Do you see your answer somewhere?
Yes.
See. Very good. Question 5. This is a slope field, right? This is called what? A slope field. This actually always comes up in the exams. If the line is heading like this, like toward the northeast, let's call it, that means we have a positive slope. If the line is heading downward, let's say southeast, we have a negative slope. So looking at these lines here, do you see any of them heading down, or are they all heading upwards? Is the plane landing or is the plane taking off?
The left side is going up.
Uh-huh.
The right side is going down.
But is it ever landing?
No.
Or is it always going up?
Just, yeah,
So it's always going up. That's what you mean. So the plane is always taking off. Okay? So that means that you must always have a positive slope. Okay. So with a positive slope, the best thing to go look at is the square powers because square is always positive, correct?
Yes.
So A is possible, B is not possible, C is possible, and D is possible. Okay. Now, let's see what's common between A and C and D. Or no, you know what? Look at A and D. What do they have in common?
The denominator.
They both have the same denominator. Okay. But how are they different?
Numerator.
The numerator. Y squared. So basically, okay, so basically, if we look at A, right, it has y squared in the numerator. That means that as we go from left to, or sorry, as we go from down to up, right? Let's say from the origin to up, the y will get bigger, right? And so the numerator will increase. And if it does, the slope becomes more steep, right? Or positive. Let's look at it though. As we are going from the origin to the top, is the slope becoming more positive or is it staying the exact same? Like if you're comparing this column, as we're increasing up with the y, is the slope ever changing or is it the same exact steepness? Same, right?
Yes.
And even if we compare this to itself, this to itself, the slope steepness is not changing when the y is changing. That means your equation must not have a y. So A is going to be off. Either C or D, okay? Either C or D. So how are they going to be different from each other? They're both going to be positive, okay? But let's look at this guy. Here, as we go from left to right, let's say as we go from the origin to x of 2, okay? Will this have a vertical intercept? I mean, a vertical asymptote? You know what that is?
Yes.
So right now, if I equalize this to 0, and if I squared everything, x is equal to 2. That means I have vertical asymptote at x of 2. So come here and look. Do I have vertical asymptote at x of 2?
Yes.
I do because it's all empty. So it has to be choice D. Question 6. The function is defined by this guy. At how many values of x does f have a discontinuity? So discontinuity basically means that this here, right? If I were to equalize it to 0, I would get a certain x value, correct?
Yes.
Okay. So that means I will do x cubed minus 1 is equal 0. X cubed is equal to 1. So x is equal to 1 as well. That means if I were to plug in 1 in here, I would get a 0 on the bottom, and that would give me a vertical asymptote. And a vertical asymptote is called a discontinuity. Okay? So we're going to have a single discontinuity at x of 1, which is choice B. All right? Let's move on to question 7. Which of the following is a solution to the differential equation? Whenever they say solution to the differential equation, they're essentially meaning that you gotta differentiate, you gotta do what's called separation of variables, followed by integration. Okay? That means we're gonna be bringing that y down, the y goes down, and the dx will take its place. And now we can integrate both sides. Do you know what's the integral when you have a single thing in the bottom, like a single power? Ln. Yeah, ln. So you're going to have ln of the absolute value of y. So right now, if you have integration of 1 over x dx, you get ln. That's the rule that you have to know. And the integral of 0.3, when you integrate a number, what do you get? Do you know that? When you integrate k, which is like a number, you get kx plus c. That means I have to add to the 0.3 an x plus c. Now the y is positive, correct?
Yes.
So the absolute value can now just disappear because it's positive. So ln y is equal 0.3x plus c. Now they're saying the initial condition is when x is 0, y is 10. So when x is 0, y is 10. That means ln of 10 is equal to 0.3 times 0, which is 0, which equals to c. So now c is equal to ln of 10. Now go back to your equation, bring it here, and replace the c with ln of 10. Now question, how do I remove the ln on the left side?
E to the power.
How did you know that? E to the power of that, e to the power of these guys. So, e to the power of ln y, e with ln go away, you get y. Here, e to the power of ln 10, the ln will go away and the 10 will go down. But the e will stay for the 0.3x. That's going to be our equation. Y is equal to 10, e to the power of 0.3x, which is
A.
Okay. Question 8. Whenever you see this guy here, they're essentially talking about a derivative. Okay. So you have to actually isolate the function before you do anything. Okay. So what is your function? You always look at the last part, which is this one. Okay. So you're going to have e to the power of negative, and don't put 1, put x, because the x was a 1. That's why here there's a 1. Could be a 2, could be a 3. Okay. That is your function. But like I said, this equation is for derivative. That means now you actually have to differentiate. So do you know how to differentiate e?
Yeah.
The first thing is you copy paste it. And the second thing is you multiply it by the derivative of the power. So what's the derivative of negative x?
-1.
Exactly. So now your function is going to be -1 over, you can bring the e down to make the power positive.
Do you put -1 as well or no?
Sorry?
X -1.
No, now you plug in this 1 that was there in the beginning. Now you plug it in. So you get -1 e to the power of 1, yani -1 over e, which is a. Not that bad, right? So here we have secant x times tan x. Secant x is going to be the a term and tan x is going to be the b term. So they want the f prime. That means we have to use the products rule, or the product rule, which says a times b prime plus a prime times b. So a and b prime is the derivative of tan, which is secant squared. A prime, which is the derivative of secant, which is secant tan, and b is just tan x. So I'm going to be getting secant cubed x plus tan squared x times secant x. It's going to be choice A. Question 10. A particle moves along the x-axis, so at any time that's more than 0, this is the acceleration equation. You want the position. Do you know how to get position from acceleration? Not yet? You have to integrate one time to get velocity. You have to integrate a second time to get distance. We have to integrate twice. So let's do the first integration. So you're going to have to do 4 over t power of 2 dt. But like I told you earlier, I don't like to work with a power that's in the denominator. It makes my life harder. Just bring it to the top before you do anything else.
Yes.
So you're going to say integration of 4t minus 2 dt. So how would you integrate t to the power of -2? Integration rule, don't forget, was x to the power of n dx is x n plus 1 over n plus 1. So t minus 2 plus 1
and
over minus 2 plus 1.
which is
Okay. Plus, of course, c. Let's simplify that. So 4 over negative 1 is just negative 4. And yeah, so that's going to be your first integration. Now, what do? We do the integration the second time. So I'm going to say integration of negative 4 t minus 1 plus c dt. Now, let me teach you something. This rule is true, but not for x to the power of negative 1. No. In fact, if you have integration of x to the power of negative 1, that means you're integrating 1 over x. And I just told you earlier that if we integrate over x, you get ln. So that means that before we integrate here, let's make that t in the bottom. Now, so that t will become ln, right? Upon integration. So negative 4 ln t plus ct plus a new c, which I will call d. Okay? So which one is our closest answer?
C.
C. Now, of course, someone is going to say, but we don't see CT, we don't see D. It's very possible that C was a 0, and very possible that D was also a 0.
Because they are constants.
Maybe it could be 0, it could be a number, but we don't know. Well, our closest answer is going to be C. Okay. Question 11. A cell phone was plugged into a charger. The battery life of the cell phone in percent of the battery remaining is given by the differentiable equation. Which of the following is the best interpretation of p prime? Now, do you know what p prime would mean to a function?
So basically got derivative.
So the rate.
Right.
Okay, the rate.
Instantaneous.
So p is the battery life, and p prime is the rate of whatever. Okay. So look for rate in your answers. Oh, and by the way, whatever the unit was of battery life, it was percent, right?
Yes.
It was percent. So this is percent. P prime has to be percent per time. So that means I can, per one time, yani. Per one time. Which in our case was what? Yeah. So basically, it's not going to be B because they have per time, right? And let's see, during the first 10 minutes.
Can be D as well.
Sorry?
D as well.
It
Right.
cannot be D as well, so it's not D. So either A or C, okay? So it was changing at the rate. I said rate. I did not say average rate, I said rate. C says average rate. That's not okay. Okay? So 11 is going to be choice A. 12. Here, what I would recommend you do is that you expand the brackets. Okay? Okay. So let's expand. So x squared minus 2x plus 2x minus 4 over. Expand this bracket, so 2x minus x squared minus 10 plus 5x. So you're going to have x squared minus 4, 4 here, minus x squared, 2x plus 3x, 7x, minus 10. Okay? And now I'm going to do x squared minus 4 minus 4x squared plus minus 10. Okay.
Don't you multiply by 4 as well? Yeah.
Oh, sorry. Yeah, 40. Now that I expanded, okay. So shall we
Plug in.
plug in 2? If I plug in 2 in my,
Numerator will be 0.
yeah, so I'll get 0 over 0. So no, don't plug in the 2. Don't plug in the 2. Okay. Okay. Let's try something else. So that now work. How about I try to cancel the x of minus 2 with the 2 minus x somehow?
We multiply by negative.
Yeah, so what I could do is I could essentially factor out the negative from the 2 minus x. So negative 1 times x minus 2. And now I could cancel these guys out. And now applying a 2 is not going to give me a 0, and the denominator is going to be fine right now. So I'm going to have x plus 2 minus 4 x minus 5. I don't need this anymore. So x plus 2 minus 4x plus 20. Shall I apply the 2 now?
Yes.
So 4 minus 4 times 2 plus 20. So 4 over 12. So 1 over 3. Good?
Yes.
All right. Question 13. You want your f to be decreasing. For the f to be decreasing, that basically means that your f prime has to be less than 0. Okay. So now what we could do is we could equalize our f prime to a 0, and then we can find something called the critical point, and then we can assess it, the left and the right of that. Okay. So right now, if I make this into a 0, I'll get 3x squared plus x minus 4. Okay. So how would I factor this guy? Quadratic?
Or like
Let's check. 3x, x, 1, 4, right?
yes.
Plus, minus. Yeah. So you're going to get x of 1, negative 4 over 3. These are called our critical points. We can now use them to assess if the f prime is negative or positive to know if it's decreasing or not. So now we're going to say, here we have minus 4 over 3, and here we have a 1, x minus 2, x of 0, x of 2. Where do you plug these points? We plug them in the f prime, essentially. Okay. Actually, let's just plug in minus 10. I think it's easier. Yeah? So, if I were to plug in a minus 10, will I get a positive or a negative number here? There's no calculator. Positive, right? Because the x squared is going to make it 100. So positive. If I plug in the 0, no, I get negative 4. So it's negative. And if I plug in the 10, I also get positive, right? So it's decreasing between negative 4 over 3 and 1. Okay, so it's not going to be choice A, because choice A goes all the way to negative infinity. And it's not going to be choice D, because it goes all the way into infinity, right? And so it's either going to be B or C. But Now, let me just erase things to make our life a bit easier. What I can do is I can go now and check the second condition, which is concave up. You know what that means to be concave up?
Like opening up.
No. It means you take your second derivative, you find your second derivative, you equalize it to 0, you find the inflection point, and you also do a sign test. So now, let's take our second derivative. So what's the derivative of 3x squared?
6x.
Derivative of x?
0. No.
1. Equalize your second derivative to 0. X equals to minus 1 over 6. That's called an inflection point that we just found. Okay? And now you must plug in within the second derivative. So let's say negative 10 plug in, and let's say you plug in a 0. And where? In your second derivative. Here would be negative, and here would be positive. If it's positive, it's concave up. If it's negative, it's concave down. So it's concave up when the x is bigger than negative 1 over 6. Bigger than. So it cannot be B. Okay, so it's going to be C. Question 14. Okay, so if that has relative extremum, that could be meaning a minimum or a maximum. We don't know. So what do? We should take our f and we should differentiate. We should also equalize it to 0. Okay. And we should replace x there with a 9. So let's differentiate. Do you know how to differentiate root of x?
Say x 1 over 2.
It becomes 1 over 2 root x. So the k doesn't change. Times 1 over. So k times 1 over 2 root x. Plus. Like I told you before, I don't like differentiate when x in the bottom. And now differentiate. So does that mean you bring the minus 1 down? And you add a minus 1. So minus 2. And now we can equalize our prime to 0. K over 2 root x minus 1 over x squared. Good. And now what? Switch this guy to the left side. I think it's better. So we can equalize things. K 2 root x. Okay, plug in the x of 9. So 1 over 81 k over 2 times the root of 9, which is
3.
1 over 81 k over 6. So k is equal 6 over 81. And I think if we simplify by dividing by 3, we'll get 2 over 27, right? Which is B. 15. A particle moves along the y-axis, so its position is given by this equation. That's the position equation. What's the position when it changes from moving down to moving up? So do you know what that means, moving down to moving up? Moving down means the velocity is negative. Moving up means the velocity is positive. So of course, to go from negative to positive, it has to become 0, right? Because right now, if you draw it, so to go from negative to positive, it has to become 2. What they're actually asking you to do is to find the velocity equation and find out when it becomes 0. So, how do you find the velocity equation? You must differentiate the position equation. So 1 over 3 times the derivative of t cubed. Do you know what that is? 3t squared. What's the derivative of 4t plus 3? 1 over 3 times 3.
Cancel out.
1. Now you can equalize your velocity to 0. See at what time will the velocity become 0. So t minus 3, t minus 1. So either t1 or t3. Okay. Now we should check the signs of the velocity to see when it's going from -2 to positive. So plug in here a time of, I would say, half. Plug in here a time of 2. Plug in here a time of 10. So right now, if you plugged in half in here, what do you get? Do you get positive or negative? You get 1 over 4 minus 4 times half, which is 2, plus 3. Then you get a positive number, right? So moving up. Okay. Now, at the time of 2, if you plug in 2 in there, you get 4 minus 8 plus 3. Yeah, negative. Okay. And then if you plug in the 10 in there, you get 100.
Positive.
You get positive. That means it's moving from down to up at the time of 3. So now, we didn't answer the question yet. We should now do it. We should now plug in the time of 3 they want in the position equation. Okay? Let's plug in the time of 3 in the position equation and see how much we get. So 1 over 3, 3 cubed, minus 2, 3 squared, plus 3 times 3, plus 4. 1 over 3 times 27 is 9. 2 times 9 is 18. 9 plus 4. So minus 9 plus 9 plus 4. So B. Good. We answered it. 16. The slope means what? F prime. Let's take this guy and find the F prime, right? So 3 minus 2y, y prime. You know what I'm doing right now, right? It's called implicit differentiation. You know what this is? Okay, so look, we're differentiating the y and the x at the same time. Together, which is called implicit differentiation. Then it doesn't matter, but
What about the 11? Do you leave it like that?
becomes 0. So 3x becomes 3. Y squared becomes what? 2y times y. That's why it's called implicit differentiation. Minus 6y becomes what? Minus 6 times y. The whole thing is equal to 0. So we're going to have, let's just put the y prime on one side. So 3 is equal to 2y times y prime plus 6y prime. You should now isolate the y prime. Factor out the y prime. 2y plus 6. So y prime is equal to 3 over. Very good. Now what? We can now plug in the y of 4. So 3 over 2 times 4, 8 plus 6, 3 over 14. Very good. All right, question 16. Right now, if I apply 0, what's the cosine of 0? Do you know? Not yet? 1. What's sine of 0? Nice. So we're going to have E 0 minus ln 0 plus 1 minus 1 over 0. So E of 0 is a 1. Ln of 1 is a 0 minus 1 over 0. 0 over 0 is not allowed. It's called indeterminate form. which now lets us do something called L'Hopital rule. So what does L'Hopital rule mean? We differentiate the top and the bottom separately from each other. Okay, let's start. So what's the derivative of e to the power of 2x? So look, when you differentiate e, the power of 2x, you will basically copy paste e to the power of 2x and multiply by the derivative of 2x, which is 2. So we're going to have 2e 2x minus. When you differentiate ln, you do 1 over, copy paste the interior, which is x plus 1. And on top, multiply by the derivative of the inside. What's the derivative of x plus 1? Just 1. So that's why just 1. Minus. What's the derivative of cosine? Negative sine. And what's the derivative of the interior, which is the pi x? Pi. Because if you differentiate kx, you get k. What's the derivative of sine? And what's the derivative of pi x? Pi. And now we can plug in x of 0. But first, let me just make this negative into positive. And I'll plug in the x of 0. Because of here. So 2e0 minus 1 over 1 plus pi sine of 0 over pi cosine of 0. So e to the power of 0 is just a 1. So 2 times that is just a 2. Minus 1 plus 0. Pi times 1. So 1 over pi is the answer. Okay? Which is B. Question 18. A store sold an item over a 16-month period. The total number of items sold up to time t is modeled by the twice differentiable function, where t is the number of the months since the store started selling the item. For the first 8 months, S prime is increasing. Look, when they say S prime, they mean the slope. When they say it's increasing, that means the slope is increasing. The slope is what? Increasing. So it's becoming more steep. So look for more steepness from 0 to 8. Is this becoming more steep? Wait,
Yeah.
let's just... is that becoming more steep? Imagine you're climbing the mountain. It's actually becoming less steep. Right? It's easier to climb over time, basically, because it's becoming less steep. And if you want to know, like in more detail, let me show you a trick. So look, this is the, let me use this color. That's the slope then. The slope becomes this. The slope becomes this. The slope becomes this. Is my slope becoming less or more steep? Less steep. So it's not going to be A. Is my slope here becoming more steep from 0 to 8? Not really, because look, here, good, here, good, good. But then what? It's becoming flat. So it's not good either. Is my slope becoming more steep in D? No, it's becoming flat as well. So what's the answer going to be? C. Let me see. Question 19. So basically, do you know the integration of... Sorry, do you know how to get the inverse of sine upon integration? Or you have not learned that yet? Okay. So look, if you have du over the root 1 minus u squared, and if you integrate that, you get inverse sine of u.
Ah, yeah, I remember this.
Good. So this guy here will give us the inverse sine of x, basically. So it's not A and it's not B. Okay. Now, how would I go about integrating that guy? Integration of 1 over 1 minus x under the cubic root. dx. Do you know how to do that? Or not yet? Okay. There is something called the u term. Whenever you run into these complicated problems, take your denominator, right? In this case, it's 1 minus x, and say u is equal 1 minus x. So what's du going to be? Minus, when you differentiate x, what do you get? 1. So minus 1. Whenever you use the du term and the u term, when you differentiate x, it becomes not only minus 1, it also becomes minus dx. Yani minus 1 times dx. So minus 1 times dx is just minus dx, right? So dx is equal to minus du. Agree?
Yes.
Okay. Now come here and replace 1 minus x with u, and replace dx with minus du times minus du. Now I told you before, I don't like to integrate when something is in the bottom. So right now it's u to the power of third. If you take it to the top, yeah, let's put that negative on the outside. U to the power of negative third du. How would you integrate that? Do you know? What was the integration rule? xm plus 1 over m plus 1 plus c. So here you should add 1, 2/3, and divide by the same exact power. Now, this 2 over 3 gets flipped when we bring it to the top, right?
Yes.
Becomes 3 over 2. Okay, and actually this is gone, plus c. So 3 over 2, instead of the u, bring back the 1 minus x, right? 1 minus x. The 2 over 3 means 2 on the inside and root of 3 on the outside, plus c. And I think right now we can tell it is going to be choice D, correct?
Yes.
Question 20. Whenever they say, we saw this earlier today, whenever they say particular solution of differential equation, that means you have to do separation of variables. You also have to integrate both sides. So let's do that. So you're going to have dy over 1 plus y is equal cosine x dx. Okay. What do we do with the 1 plus y? I would replace it with u. So I'm going to say u is equal 1 plus y. So what's du? The 1 becomes 0 when you differentiate.
Yes.
And y becomes dy. So now, instead of dy, I'll put du. And instead of 1 plus y, I'll put u is equal integral of cosine x dx. You know what happens when you integrate x when it's in the bottom, right? What do you get? Ln. So I'll get here myself ln of u. And when you integrate cosine, what do you get? Sine. No, not negative, just sine. Now, look. Now you can replace the u with 1 plus y again. Okay? So ln of 1 plus y absolute value sine x plus c. Now, since my y is 2, 1 plus 2 is 3. So since the inside is positive, remove the absolute value. Okay. Now look, they said the initial condition is when x is 0, y is 2. So come here and replace the y with 2. And replace the x with 0. What's the sign of 0? 0. So that means that ln 3 is equal to c. Now, let's continue. So I'm going to say ln of 1 plus y is equal sine x plus ln of 3. How would I remove the ln? I have to take e as the base. So e with ln will go away. You get 1 plus y. E with ln of 3 becomes 3. E sine x. So y is equal 3 e sine x minus 1. So y is equal 3e sine x minus 1. Now, they're saying apply pi over 6, I mean, right?
Yes.
So instead of the x, put pi over 6. Do you know what pi over 6 is? I mean, sine pi over 6 is?
Yes.
How much is it?
26.
It's actually half. And that means we have to do e, the power of, to the square root, minus 1. So d. Good. That was a bit complicated. Let's erase everything. Okay. The first derivative is given by this. At what value does the f attain the absolute maximum? Do you know what that means? Whenever they say maximum or minimum, you must differentiate and find the x by equalizing your derivative to 0. But it's already differentiated for you. So just equalize it to 0. So 4x is equal 8, x is equal to 2. You must now do what? You must now assess those 3 points. What 3 points? X of 2, x of 0, x of 3. So I must do f of 0, f of 2, f of 3. You must plug them in the f. But guess what? We don't have the f. We only have the f prime.
Yes.
How do you go from f prime to f? You have to integrate. Integrate f prime to get f. So what's the integral of 4x? 4 doesn't matter. How do you integrate the x?
So you keep it.
No, it was xm plus 1 over m plus 1.
So it's x squared
Over 2.
2.
Minus, how do you integrate a number? Just put x to it.
Yeah.
Right?
Integrate x.
Plus c. Okay. So you get 2x squared minus 8x plus c, right?
Yes.
Now plug in the 0. So you're going to get c. Plug in the 2. So 2 times 4 minus 8 times 2 plus c. 2 times 4 is 8. 8 times 2 is 16. So 8 minus 16 is negative 8. Now plug in the 3. So 2 times 3 squared minus 8 times 3 plus c. So 2 times 9, 18. 8 times 3, 18 minus 24.
Negative 6.
So they want the maximum. Which one here is the biggest number?
Of 0.
Exactly. And you can choose any c you want. You can choose 10 if you want.
Yeah.
Let's just apply c of 10, for example. This will become 10. This will become 2. And this will become 4. So f of 0 is the biggest. So at what value of x? At the x of 0. 22. Okay. So look, is the function continuous for all the x's? Of course not.
No.
Because you have a denominator that can become 0.
0.
So you're going to say x squared minus 4 is equal to 0.
0.
X squared is equal to 4. So what's x? Plus minus 2. So it's going to be discontinuous at 2 and negative 2. $23. Okay, so they want us to integrate this guy, right? So that means you do from negative 2 to 5. Let's just separate them. Fx dx plus integration from negative 2 to 5, 1 dx. From negative 2 to 5, what is my area, essentially? It's a triangle, it's a rectangle, and one more triangle, correct?
Yes.
So this is going to be negative half. See, it's negative because I'm under the x-axis.
Yes.
Times the base, which is 2,
2.
times the height, which is 2. Now, let's take care of this rectangle. It's also under the x-axis, so negative 2 times 3. Now let's take care of this triangle here. Under the x-axis, negative half by base by height. This becomes negative 2. This becomes negative 6. This becomes negative 2. Add them all and you get negative 10. So negative 10 plus, what's the integral of 1? What's the integral of any number? Just put x on the number. So 1 times x is x. And this integration becomes a vertical line from minus 2 to 5. So minus 10 plus. Instead of x, put 5 minus. Right? You should do, one time you put 5, then minus sign, then put negative 2, right? Okay. Minus 2. So minus 10 plus 5 plus 2, yani negative 3. So choice C. Okay. 24. Do you know what this means?
F of A minus F of B over.
Like, what does it mean? It means the slope. The slope is negative 3 over 5. The slope is tangent line. Has to be the same. So A. Okay. 25. Okay. Now, do you know what complete the square means? Okay. So we have to complete this square. So x squared minus dx plus 10. Think about, okay, so let me tell you what's going on here. How do you complete this square? Like, what do you do with this guy? You know?
Try to like separate them.
Okay, so look. To complete this square, you have to take the b, divide by 2, and square it. So what's the b term here?
Negative 6.
Nice. Over 2, and squared, what do you get?
9.
So this 10 has to become two numbers. 9 and 1. And this will be my square. Now, what do? Why is it called a square? Because it's one bracket with a square. Now, you take that x squared, and you do what with it? You square root it.
Yes.
You take that 9, and you square root it.
3.
You take that negative, and put it here. So now we're going to have dx over x minus 3 squared plus 1. Okay. I can now say the u is equal to x minus 3.
Yes.
So what's the u? Dx.
Dx.
So now, instead of dx, I'll put du. And instead of x minus 3, I'll put u squared minus 1. I mean plus 1. And you must know that this is going to give you inverse tangent of the u. That means you must see arctan. Arctan means inverse tan. So it is D. Okay. 26. This is called the Riemann sum notation. I'm assuming you've not reached there yet.
Yeah.
You have?
No.
You take the 1 over n and you equalize it to b minus a over n. So if you take out the n with the n, You're left with what? B minus A is equal to 1. That means the top interval minus the bottom one is equal to what? 1. So it's not going to be A, because half minus 0 is half. It's not going to be B either. It's going to be either C or D. Okay. Now, the next thing you do is that you come to this guy. Okay. And you say K over 2N is equal to A plus B minus A over N times K. Okay? That's like a rule. That's what? A rule. This is the A, the bottom number. So instead of A, what do you put? 0. Cancel the N with the N. Right? And if you cancel the K with the K, you will get 1 over 2 is equal to B minus A. But that's not possible because we know that B minus A is equal to 1. So where did that 2 come from? That 2 is not part of X. That 2 means we're dividing X by 2. Does that make sense, or is that not clicking?
Yes.
Okay. So look, let's just recap it. Okay, so now we know that B minus A is equal to 1, correct?
Yes.
Okay. Okay. Let's look at this guy for a second. Okay. So X is equal to A plus B minus A over N times K. That's like a rule.
Yes.
Okay. We know that the A is how much?
0.
0. So X is equal to 0 plus B minus A is already a 1. K. So X is equal to K over N.
Yeah.
But here we have K over N over 2. You know what that means? They're dividing our X by 2. And there is already a 2 in there. So it's going to be choice C.
C.
27. There's a rule that says whatever power you have, whatever number you have to the power of infinity is much bigger than x to the power of n. Like much bigger. Okay? Or much bigger than infinity to the power of n. So know this rule, please. So here, which one is going to be bigger, the bottom or the top? Key is a number, by the way. So which one is bigger, bottom or top?
Bottom.
Bottom. Because you're going to have infinity to the power of 5 over 2 to the power of infinity. The bottom is bigger. So it's like saying small infinity over huge infinity, which is like saying 1 over infinity, which is a what?
0.
A 0. And they want a 0. So it's choice A. Let me tell you why the others are wrong. This will be e to the power of infinity, infinity power 50, which is like saying huge infinity over small infinity, which is infinity. So B is out. This is like saying big infinity over small infinity, infinity. And here, whenever you have complex powers, take the coefficient of the highest power. So 1 over 25. So also wrong. Okay. Okay. Very nice, right? So here we got, I would say here we have two shapes, right? What do you think? I think we have two shapes because they're looking for the solid, which is shaded. And so we should separate it from here to here. That's a shape. And then from 6 to 12, that's a different shape. Do we agree?
Yes.
Different shape or what? Different shape. That means you must do one time from 0 to 6, and one time you should do from 6 to 12. So it's not C, right? And it's not D. Okay. Now, whenever they say the cross section, that means you don't put pi on the outside. You don't. So B is out. Okay. But how do we get these things? It's a square. So what's the area of a square? Side squared. So this is one side. When you square it, 1 over 36 x squared. That's a different side. When you square it, sine pi x over 12. And that's how you get those things. So it's choice A. Okay, question 29. Whenever they ask for, where is it not differentiable, you must first check the continuity. Check where it's not continuous first. Because if it's not continuous, it's not differentiable either. So how do we check what's going on? Check with the endpoints. So check with a -1, check with a 1, and check with what makes the inside of the absolute value a 0. So what makes the inside here a 0? What x?
1.
0. Yeah. So that means we actually have to check for 3 points. X minus 1, x of 0, and x of 1. Okay. Let's check first of all the continuity, which means does the left-hand limit equal the right-hand limit? That's the question. Does left-hand limit, because it's less than, right-hand limit, it's more than 1, -1. So x squared plus 3x plus 2, 1, we don't know if it's same or not, root of x. Now instead of the x, put -1, so -1 squared is 1, minus 3 is 2, right? So how much do we get? 0. And here, because my x is negative, you must turn the absolute value on the inside into a negative as well. So 1 plus x. Now plug in -1, so 1 minus 1 is also a 0. So we know it's continuous. Okay? We know it's continuous, but do we know if it's differentiable or not? Not yet. Now what do? We change left-hand limit to left-hand derivative. We change right-hand limit to right-hand derivative. So now differentiate them. So differentiate this guy, 2x plus 3. Differentiate this guy, 1. Plug in -1. So 2 times -1 plus 3 is 1. 1 is equal to 1. That means it's differentiable at -1. So -1 should not be in the answers. So it's not D. Okay? Okay. Let's now check if it's continuous or not at 0. So left-hand limit, right-hand limit. We're doing this for the 1 minus x. 1 minus. If x is less than 0, you put minus on the inside. And if x is bigger than 0, you put plus on the inside. So 1 plus x, 1 minus x, and now we can differentiate. Left-hand derivative. Let's make it sure it's continuous first. So plug in 0. 1 plus 0 is 1. 1 minus 0 is 1. So it is continuous. But is it differentiable or not? Let's check. Left-hand derivative, right-hand derivative. So If you differentiate this guy, it becomes a 1. Differentiate this guy, it becomes a minus 1. Are they equal to each other? No. So it's not differentiable at 0. So it has to be either A or C, but not B. Okay? Now we just have to check the continuity and also differentiability at x of 1. Let's erase some stuff.
I'll try solving it.
Yeah. So let's check the continuity at x of 1. So let's check the left-hand limit and right-hand limit. So the left-hand limit will be less than 1, yani 1 minus absolute value of x. Right-hand bigger than 1, x squared minus 1. Since the x is 1, make the inside positive. And now plug in the 1, so 1 minus 1, which equals 0, and 1 minus 1, which is equal to 0. So it's continuous.
Yes.
The question is it differentiable or not? Left-hand derivative, right-hand derivative. Okay, so you will differentiate that one into minus 1 and this one into 2x. Plug in the 1, so 2 times 1 is a 2. Are they equal to each other?
No.
No, so it's not differentiable at 1 either. So it's going to be choice C. Question 30. The average rate of change. Do you know what that means?
So
that means finding the slope. So
what if it's not average? It's not about the slope.
It's always average rate of change on your slope. So f16 minus f4, 16 minus 4. So copy paste the equation, but replace the x with 16 one time with 4. So 1 over 8 minus half, 12. 1 over 8 minus half, making the same denominator, so 8 here, 1 minus 4. So minus 3 over 8 over 12. That's like saying minus 3 over 8 times 1 over 12. Divide by 3. This will go away. This becomes a 4.
Negative 1.
Oh, wait. Is that not true? Did I make a mistake somewhere? 2 over 16. Okay. Where's my mistake? Okay, so 2 over 16. I did that. 2 over 4. So, actually, no, there's no mistake because this question is 2 steps, so we're good. So we're going to get minus 1 over 32. Now, this is the average rate of change. The question says, for what value of x is the average rate of change equal to the instantaneous rate of change? So the average rate of change we just found to be negative 1 over 32. If it's instantaneous, that means the f prime. So now, how do you differentiate 2 over x? First, bring the x to the top, right?
Yes.
And now differentiate. So 2 times negative 1, x minus 2. So minus 2 over x squared. You will equalize that to negative 1 over 32. So x squared is equal to 64. X is equal to 8. So it's B. Metal rod has a temperature of 75 degrees Celsius. Temperature of the rod is increasing at a rate. Okay. Increasing at what? At a rate. Okay. So They want the temperature. So to go from rate to temperature, so no rate, you have to do what? You have to integrate. Okay? So we start with 75. That's the original temperature when the time is 0. Plus the integral from 0 to 10. Integrate what? Integrate the rate. So 47e minus 0.2 t dt. We can now use Desmos for this one. So in Desmos, go here, get the keyboard out, and type 75 plus, go to function to look for integration, from 0 to 10. Put your function, 47e, so go to ABC and click on E, go back, make it power, negative 0.2 x for t, and here come down and put dx. So go to ABC and click dx. 278 0.196, right? So 278 will be the answer. How easy is that? 77. Okay, they're asking us for the limit of x approaching 1 for f of x and g of x. When x approaches 1, how much is the f of x? So this is the x of 1. How much is the f of x? Would you choose the dot or the whole if they say limit? Whole. So it's 2. Yeah. And for g of x, when x is 1, how much is the g?
Negative.
Negative. So it's negative 2, right? Was hard? Not again. 78. So do you know what this means? This means differentiable. So there is no whole and there is no discontinuity. Okay? From 2 to 4, is there a whole?
Yes.
Yes, there is. And there's also a jump, right? From 4 to 6,
Yeah.
is there a hole?
Yep.
No, but look, it's open interval. Yeah, I don't include the 6.
Okay. No.
So we choose it. Good. 79. They're saying it's a semicircle. Whenever they say the cross section is semicircle, that means the equation they gave you is the actually wait, here it says the hypotenuse. So this is going to be the diameter, what they gave you. Okay? And you're going to find the area of a semicircle, which is what? Which is pi r squared over 2. Well, that's diameter. So what's our radius? Half diameter, right? So divide that by 2. You get negative 3 over 16 x minus 16. And now you'll do pi over 2 r squared. So take this guy and square it. Also, they want the volume. So you're going to say volume is the integral of this guy from 0 to 16. So pi over 2 minus 3 over 16 x minus 16 squared dx. We should now integrate this guy. Good. Let's go to Desmos. So on Desmos here, let's just do integration. So go to functions, int, from 0 to pi over 2 So pi is here over 2, open the bracket, negative 3 over 16, x minus 16 squared dx. And I got 75.398. So it's going to be A. Okay. 80. We have here the rate of change, and we are looking for at what time is the water level in the lake equal to the water level at time of 0, right? So in the beginning, there was no water, right? But they're going to be adding water. So what you basically want is you want to have a combined area that's going to give you a 0, essentially. So a combined what area that's going to give you a 0. So let's see what's going on here. So look, the area from here to here is how much? That's a rectangle, and that's a triangle, both under the x-axis. So a negative base times height, and then negative half by base by height. So negative 2, negative 1, negative 3. And now pick an area above the x-axis that's also a 3. So they cancel out, right? Let's see this triangle. Half by base by height. That's a 3. So they cancel out when the time is 5, correct?
Yeah.
And become 0. So T of 5 has to be there. So it's not going to be D. Okay? And there's nothing before time of 5 that makes it 0. So it's not time of 2. So now it's either going to be A or B. Let's check the time of 12. So here, this is going to be, we said, negative 3. This guy is 3. This guy is what? Negative half by base by height. So negative 3. How about this guy? Triangle and rectangle. So half by base by height and rectangle, which is 2 times 1. So 1 plus 2, which is 3. So they what? They also cancel out at time of 12. So B. Good. Is it a bit cold for you?
Nice.
Okay, so 81. This is F, and G is the integration of F, starting from 1. So basically, yani G is the area, right? So when x is 0, to integrate from 1 to 0, we have to go backwards. And if we go back, it's going to be negative. Okay? It's going to be what? Negative. But look, let me show you something. It's already negative here, correct? So when you go back, it's negative, and it's already negative. So positive. So that means when you are on the left of 1, you should have a positive area, not a negative one. So A is going to be out. Okay. And C is going to be out as well. Okay. Yeah. And so now how is B and D different? They both have the same first row, and they both have the same third row, and they both have the same last row. So only compare this, 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 and this. Okay. When we go to 0.5, so let's say from here to 0.5, which is here, do you think this is equal to, because look here, they say if we go back to 0, you would get 16. So if we go back to half, do we get half or do we get less than half? Because look how small the area is.
Less than.
So it's not going to be 8,
It's
right?
not gonna be.
No. So it's going to be D. Okay. All right. 82. Table gives the value of differentiable. Right, so we want to find the h prime. You got to take this and you got to differentiate. So you're going to say h prime of x, f prime, g of x squared, okay, times g of, prime of x squared times 2x. Replace the x with 3. So f prime, g of 9, g prime of 9, and 6. So f prime, g of 9. So when x is 9, g is 4. G prime of 9. Now when x is 9, g prime is 5 times 6. F prime of 4. When x is 4, f prime is negative 2. Negative 2 times 30. So negative 60. Okay. 83. So they want us to, look, let's just see what's given, right? The truck is 50 meters. I'll call this the y. I will call this the x. The truck is traveling toward the intersection point at 15 meters per second. That means the dy over dt. Because the truck is approaching, distance is becoming less, right? So put a negative on that. And yeah. And the car is moving away at the rate of dx over dt of 25. Moving away is positive. They want the rate of the distance h between the two vehicles changing. That means they want the dh over the dt. So you're going to say h squared is equal to x squared plus y squared. So h is equal to the square root of x squared, which is 120 squared, plus y squared, which is 50 squared, and you get 130, right? And now we can take that equation, we can differentiate it. So 2h dh over dt, 2x dx over dt, 2y dy over dt. And you can cancel every 2. Now we're looking for the dh over dt, right? So we're going to say dh over dt is equal to, h goes in the bottom, x times dx over dt plus y dy over dt. Okay, so x is 120. Dx over dt is 25. Y is 50. And dy over dt is negative 15. And h is 130. Let's use the calculator. And I got 17.307. Just see. 84. So here, this is the u term, 3x minus 2. So du is equal to 3 dx, right?
Yes.
So dx is equal to du over 3. Okay. If u is equal to 3x minus 2, and if x is equal to 1, u is equal 3 minus 2, which is 1. And if x is equal to 2, u is equal to 4. That's why it's 1 to 4. So we're going to say the integration from 1 to 4 of f of u, and instead of dx, you put du over 3 is equal to a. Now, just multiply everything by 3. This goes away, and this becomes 3a. Good. 85. Okay, so this is the graph of f prime. To have an extremum, it must be hitting the x-axis, and it has to be also going from negative to positive or positive to negative. But going from positive to positive is not going to count as an extremum. Okay, so it's not C and it's not D. Okay, what's an inflection point? An inflection point is when the slope of the f prime is 0, which is here and here, as long as the sign of the slope on the left and the right is different. So the slope here, the slope of the slope, like the slope of f prime here is positive, the slope of f prime here is negative, then becomes positive. So because of sign change, they both count as inflection points. So B. Okay, so for the points of the inflection, we have to grab the derivative of this and see when the derivative hits the 0, right, the x-axis basically, and as long as there's sign change on left and right. Let's go ahead and graph it with the window limited from here to here. So here in Desmos, you would go to functions, you click on that, you put the bracket, and then now let's put the function, which is going to be x squared tangent 1 minus 2x. Okay, let's limit it function wise, window wise, from negative 0.25 to 0.75. Okay. Yep. And that's basically going to be it. That's going to be our function, right? And we have two inflection points because our second derivative hits the x-axis and also changes the sign at 0 and also at 0.323. Therefore, the answer is going to be choice C. 87. So f of v is in hours, right? And v is the average velocity in mph. You want f prime. So right now f prime, okay. What's f prime? F of v at the time of 2 minus f of v at the time of 1 over v2 minus v1. Just like, fb minus fa over b minus a. The unit for the fv is hours, and the unit for the v is mile per hour. So hours per mile per hour, which is D. Good. Functions f and g are defined for, okay, the graph of y is equal gx is a line segment, and the graph of y is equal fx is a semicircle. Okay, so what's the instantaneous rate of change of h? That means the h prime, correct?
Yes.
So h prime is equal to, you have to use the product rule. The quotient rule. Do you know what that is?
F of b minus
B squared b times a prime minus a times b prime. So we're going to do g of x squared g of x f prime x minus fx g prime x. And instead of the x, put 0. So 0, 0, 0, 0. Okay, now g of 0 would be 2. F prime of 0, so that would be the slope at 0, which is a horizontal line, correct?
Yes.
Okay, so 0. F of 0, that means when the x is 0, what's the f? It's 4. G prime of 0, that means the slope of this line, which we can find by using points like a 4 and a 4 and a 0 and a 2. So 4 minus 2, 4 minus 0, 2 over 4, which is half. So half. Now g of 0 would be a 2. I mean, yeah, it would be a 2, and you square it, that'll be a 4, right? So minus 2 over 4, which is minus half, which is choice A. Okay, now, so the radius is increasing at this rate. That means that dr over dt is 1.15, and the radius is 0.75, right? And they want, at what rate is the area changing? That means they want d area over dt. And so d of surface area, which is ds, yani. Okay, over, yeah. All right, changing in square meters per minute. Good. So let's see about that. What we can do is we can say that so dr dt is given here, right?
Yes.
And they want the ds over dt. Okay. Now let's see what's going on here. Right now, if I were to differentiate this guy, what do I get? I get ds over dr, right, is equal to pi. And here times 1 over 2 square root 36 r squared plus r4, correct? And then in the numerator, I'll be multiplying by derivative of the interior. So what's the derivative of this guy here? 72r plus 4r cubed, correct?
Yes.
Okay. Okay. Oh yeah, and of course, because I differentiated the r, I must multiply it by dr over dt. Okay. So yeah.
dr.
Sorry?
We switch dr and dt. There's not a graphic.
It doesn't matter. Just plug in to replace every r. Replace every r with 0.75 and replace every dr over dt, which appear only once, 1.15.
We get d.
You got what?
22.8.
22 point. So yeah, ds. Yeah. Okay. So it's gonna be choice D basically. All right. Good. Question 90, the velocity is this much. At the time of 0, the position is this. What's the position at the time of 2? So you're going to do the initial position plus integration from 0 to 2. Because if you integrate position, you get velocity, correct? So 3 plus the integral I'm sorry, if you integrate velocity, you get position. And so from 0 to 2, go ahead, apply in the calculator and see how much you would get. Me plus 0 to 2. Basically that. So the answer is going to be